Very good morning. Today we start multivariate descriptive statistics, mean vector. In last class we have completed univariate inferential statistics. As I told you, the univariate descriptive and inferential statistics are the prerequisites for multivariate statistical modeling. And today formally we are starting with mean vector, which is the first part of multivariate descriptive statistics. What we will see that the univariate descriptive statistics is converted to multivariate descriptive statistics from scalar to a vector domain. And today we start with the multivariate observations, then we discuss about population mean vector and sample mean vector. I am sure that you will enjoy today's lecture, and I hope for the best. Let us see the next.
Today we will formally enter into the multivariate domain. In univariate statistics, univariate descriptive statistics, you have seen central tendency measures as well as dispersion measures. Correct. Univariate case you have seen earlier in class these lecture classes. Now central tendency you have measured in univariate case using mean, then your mode and median. These are the measures we have adopted. And under dispersion you have used range, then I think IQR, interquartile range, as well as standard deviation. Okay. Now we will see some of the counterparts in the multivariate domain. For example, mean will be mean vector. When you go for this multivariate statistics side, you will find out that mean will be mean vector, and the standard deviation, another component which is the measure of dispersion, that will be not standard deviation, its square, that is the variance. Variance will be covariance matrix. Covariance matrix. In addition, as there will be more than one variable, so there will be correlation between variables. So we will be knowing correlation matrix also. Today's discussion will be concentrated on mean vector, covariance matrix and correlation matrix. Okay. Now think in little bit on in abstraction level now, that there are a multivariate population, there is a multivariate population, and that population is characterized by a variable vector which is known as x. There are p number of variables which is characterizing the population of interest. So, it is a p cross 1 vector. What does it mean? We are saying we have created a vector x which is p cross 1 vector, where p stands for number of variables. So, there are variable 1 which is x 1, variable 2 is x 2, like variable p is x p. Okay. Now, you think that you require to collect data on these p variables. So, I am writing here, so my first variable is x 1, second variable is x 2, like my last variable is x p, and you are basically collecting data on these p variables So, you will be collecting observation 1, observation 2 like this n observations. So, essentially you are not in univariate domain, you are in multivariate domain, and you are not only in one x with several that n values, that means 1 to n values. Here you are with I equal to 1 to n and j equal to 1 to p. So, what does it mean? I equal to 1 to n, these are the number of observations, and j equal to 1 to p, these are the number of variables. Okay. Now, you think of a situation that you have your population, you know that variables, p variables are there, you identified the variables. Now, you are planning to collect data, you have not collected data, you are planning to collect data. Then our nomenclature, the way we will be writing here, we will be writing like this: the general observation will be x I j. What does it mean? X I j means that is the ith observation on the jth variable. Ith observation on the jth variable. That is why I stands for 1 to n, which is number of observations, j is 1 to p, number of variables, x I j, which is the ith observation on the jth variables to be collected. If this is the case, that means we are first writing the variable, then we are writing that what is the observation number, then we are writing what is the variable number. So, then this is observation 1, variable 1, so x 1 1, observation 2, variable 1, x 2 1. So, like this you are writing observation n, variable 1. My second my observation on the second variables will be x observation 1, variable 2, x observation 2, variable 2. So, like this x observation n, variable 2. So, in this manner you will go, then x observation number 1 on variable p, observation number 2 on variable p, like this you will be getting observation number n on variable p. This is the data matrix, and we will be denoting this as capital bold X, capital X, bold X, and the order will be n cross p. Capital bold order will be n cross p. It is visible.
Yes.
Okay. This one I am saying this is a data matrix which you are planning to collect. If this is the case, and you all know that x is a random vector, here x 1 to x p, x is a random vector, because all the variables are random variable here. So, x I j is the ith observation on jth variable, this is also a random variable. Okay. This one please keep in mind, this is also a random variable, we are writing it as random observation. So, as you have not collected data, you have just planning to collect data, any value of x I j can be found depending on the spread of that variable. You will be getting any value of this, but you do not know what is that value. So, that is why we are saying it is a random, it will be random observation, and it that x I j is a random variable, will be random variable. Okay. So, you can expect value of x I j. Getting me? You will get some, you have some expectation. So, you will see in univariate case that if x is random variable, then expected value of x is mu. So, if this is the case, then for every variable here it has also some expected value. So, that is what we will basically talk about the mean vector. Okay. So, before coming to mean vector, another two important issue is there that to be discussed here. Suppose the observation is ith observation and there is the variable is x j. This also the what will be the, I told you that the general, what I have given you here, that this is the general observation x I j. So, similarly there will be a general observation, multivariate observation, general observation, similarly there will be a general variable. Now, if it is I, suppose this one is I, this is the ith multivariate observation. So, your value will be x observation number I variable 1, observation I variable 2, like this. If I go observation I on variable j, then observation I on variable p. Okay. So, if I write that x I is the ith multivariate observation, ith multivariate observation, can I not write like this, that x I 1, x I 2, x I j, x I p, this is a p cross 1 vector, correct. Now, if I go by the variable y, so that means when I talk about the ith multivariate observation, please keep in mind that is the observation, a particular observation on all the variables. Now, why it is not that what is the in univariate case, what will happen, you will get the one value only for that observation. As it is multivariate, you are getting all all values on p variable, but the other thing, important thing is that it means all the variables are occurring simultaneously, simultaneous occurrence, that is why multivariate in nature. Now, if I go by the general, our general variable which is x j, then this observation will be x observation 1 on variable j, observation 2 on variable j, and observation I on variable j, similarly observation n on variable j. So, you will be getting a general that means observations on a particular variable, that way we will write. So, if we write like this, that x j, this is what we is that is the observations on n observation on jth variable, then this is x 1 j, x 2 j, like this, x I j, then x n j, it is a n cross 1 matrix. So, that means essentially what is happening, you have one hand this side that the observations, number of observations axis, and other hand you have number of variable axis. So, when you go row wise, you are basically talking about different multivariate observations, and when you go column wise, that means you are talking about n number of observations on different variables. That observation on n observation on variable 1 to variable p. Okay. So, but what we have assumed here, we have assumed that we have not collected the data, we are planning to collect data, and as a result all the entries in this particular matrix are random in nature. What will happen if you collect the data? When you collect data, the same thing, you will collect data on same number of variables x1, x2 like xp, and your data matrix also will be n cross p. Here also you will be getting I equal to 1 to n like x11, x21, xn1, x12, 22, xn2, then x1p, 2p, xnp. This you will get. Here also your xi1, then xi2, somewhere xij, then xip, that general observations will be there, which we can write like this, which we will be able to write like this, that xi, which is xi1, xi2, xij, then xip, that is p cross 1, and also you will be getting one general variables, that observations. So, we write that xj, if we write, you will be getting x1j, x2j, like this, xij, then xnj, all remain same. It is after data collection. Then my question is, what is the difference between the first matrix and second matrix? This is our second matrix, where we said that after data collection, and this is our first matrix, we say this is before data collection. What is the difference? The second matrix values are known. So, it is either fixed values now. From the data collection point of view, they are fixed values. First matrix, you don't know what value you will get. So, that is why in the first matrix is when you don't know anything, that you will expect some value for each of the variable, that will be mean. You also expect some deviation of different values from the mean, that will be your variance, and you also expect that two variables will be co-vary, that will be your covariance. So, that is from the population point of view. Now, let us see this data set. Okay. Now, if I ask you what is the X matrix, data matrix. So, what is the n value? N is 12. Now, months we are excluding for the time being, although month can be included as variable. For the time being, let month is excluded. Then 1, 2, 3, 4, 5. So, your data matrix is 12 cross 5. All the variables are measured for 12 observations. So, if you see this, then see this is the data matrix, this one 12 cross 5. Oh, this is not coming here, 12 cross 5. So, the left hand side matrix, the data matrix is X 12 cross 5. 12 stands for N, this stands for P. Okay. Anyhow, now we will just find out. Our aim is, first we will see the expectation of the variable values for each variable what is the expected value. Then we will see that when we collect data, what is that value. Okay. Now, you see this slide where that as there are p variables, so there are p means. These are population parameters. This mu is the vector which represent p means for the p variables, and it is mean vector and which is a parameter vector for the population. And I have written here that it is expected value of x 1, expected value of x 2, expected value of x j, expected value of x p. And you have already seen that what is the expected value of x, what we have written earlier. If your variable is discrete, you give a summation and then you say all x, x f x. Here what happened, we have basically so many variables at hand, we are writing like this: expected value of x, j stand for the variable, for a particular variable, jth variable, then we can write all x j, x j f x j when it is a discrete variable. When it is continuous, what will happen? What you write in continuous case here? You have seen continuous case, you write integration minus to plus infinite x f x dx. So, I am writing here for continuous case integration minus infinite to plus infinite x j f x j d x j. So, for both the cases j equal to 1 to p. This is your expected value. So, this when you write down for mu, what is mu? Mu is a vector p cross 1 vector which is mu 1, mu 2 like mu j, then your mu p which is p cross 1 vector. This is nothing but as we discussed now, expected value of x 1, expected value of x 2, then expected value of x j, then expected value of x p, and expectation we will calculate like this. Correct? So, when you collect data, we have two sets of matrices. One matrix we say that we have not collected data, that is before data collection. With respect to this, we are developing this one, this. So, we are saying that our topic now is mean vector. When you collect data like the one I have already given you, that 12 into 5, then our data matrix is this after data collection, and we want to compute the average value only, because we have seen in univariate case what we have seen? We have also seen that x bar is the estimate of mu. So, in our case we are writing x bar which is nothing but x 1 bar, x 2 bar, x j bar, x p bar, that is p variable average vector. Now, what is your x bar in case of univariate? You have written 1 by n sum total I equal to 1 to n x I. So, that means I can write this one now in the same manner, that this one is I equal to 1 to n 1 by n I equal sum total I equal to 1 to n x I 1 I can write. 1 stands for the variable, I stands for the observation. Similarly, second one you can write sum total of I equal to 1 to n x I 2. So, in that same manner for the jth case you can write I equal to 1 to n x I j, and the last one you can write I equal to 1 to n x I p. This is my mean average vector for the sample collected on p variables. Okay. So, we will not go for individual mean calculation or average calculation. Instead of doing this, we want to do matrix calculation, vector matrix, that matrix algebra calculation. What we will do here, see, I have, in order to calculate this x bar, we will take this data matrix first. What is our earlier data matrix was there? This data matrix was x n cross p, which we say suppose x 1 1, x 2 1, like this x n 1, x your 1 2, x 2 2, then your x n 2. So, like this x 1 p, x 2 p, your x n p, that was my sample data, and it is n cross p. You want to compute x bar from this sample data, and x bar is a p cross 1 vector, that is x 1 bar, x 2 bar, x j bar, x p bar. So, and you know the formula also, you know the general formula, suppose x j bar is 1 by n sum total I equal to 1 to n x I j, that also you know. Okay. Now, in matrix in one go you want to calculate all those things. What you require to do, that means when you calculate in matrix domain, please remember I have n cross p matrix, I want a p cross 1 matrix. I am going from, suppose this is n cross p. So, you have n cross p, you are going to p cross n. That means, what if I create one matrix which is, let it is 1, big one, symbol 1, which is all ones, 1 1, like this, there will be n ones, n cross 1. I am creating one unit vector where all there are n elements in the vector and each element is 1 only. Getting me? Now, this I want to use this unit vector with this data matrix in such a manner that I will be able to apply this computation formula and I will be getting the p cross 1 vector. Okay. So, that means, if I create like this, suppose p cross n into n cross 1, is it p cross 1 from matrix multiplication point of view? Row column. So, here number of column is number of row, equality is there. If I want to do this, that means I have to transpose this matrix. I have a matrix called x with n cross p. If I do transpose x t, this will be p cross n, row and column will be interchanged. So, I am doing this x transpose, this is p cross n, I will take a dot product, that is n cross 1. So, your resultant matrix will be, definitely it will be, this will be cancelled out and it will be p cross 1. Okay, so what will happen with this, you see now. So, your data is like this. So, I am taking now, let p equal to 2, n equal to 3, just to reduce the complexity of repeating the same calculation. Then my X matrix will be 3 cross 2, which will be like this: x 1 1, x 2 1, x 3 1, then x 1 2, x 2 2, x 3 2. As there are 3 observations, so let you create one unit vector which is 1 1 and 1. This 3 is required because my n is 3. So, I want to multiply x transpose 1. So, what I will do then, x 1 1, x 2 1, x 3 1, that is the first row, second row x 1 2, x 2 2 and x 3 2, this is my second row, because I have made the X matrix transposed. So, then you multiply this by 1 1 and 1, and we all know this one is a X transpose is 2 cross 3 and 1 is 3 cross 1. So, we will be getting a resultant matrix which is 2 cross 1. So, then matrix multiplication point of view, x 1 1 into 1 plus x 2 1 into 1. So, that is what I equal to 1 2 3 x I 1. Second one will be I equal to 1 2 3 x I 2. Now, we have seen earlier that what is x j bar, that is 1 by n, sum total I equal to 1 to n x I j. So, if I divide these resultant things by n, I will get the mean vector. Okay. So, that means I can write x bar is 1 by n x transpose this one, or you will be able to do it very easily, because this formulation is much better, because you can multivariate domain hands on that calculation type you forget. You have to use MATLAB for understanding the computational part. You can nowadays Excel is very powerful also. So, Excel also you can use. Using Excel you can use this formulation very easily. I think I will be giving you tutorial and you will have to do this, and then if you find problem, talk to me again in my chamber also, absolutely no problem. Okay. So, will you be able to compute the mean vector log given data? Now, see this slide. Suppose you take these first 3 values for the first variable and also first 3 values for the second variable, and use this that matrix multiplication. Can you not do what I said, that we are taking only 2 variable case with 3 observations 10, 12, 11, then 100, 110 and 105. So, I want to get the x bar, what we are saying, x 1 bar and x 2 bar. You can very easily you can go like this. Okay, 10, that is 33, the total is 33 here, the total will be 5, that will be 1 0 1 1 1 and 3 3 1 5. If you divide it by 3, it will be 11, that first one variable 11 and second one will be 1 0 5. So, that means your x bar is 11 and 105. that you can very easily do here also, but I am saying that you use this formulation that x bar equal to 1 by n x transpose 1. If you do like this, 1 by 3 x transpose will be 10, 12, 11, 100, 110, 105 and then 1, 1, 1. This is nothing but 1 by 3 into 33, 315, which is your same thing 11105. It seems or that means here and here there is not much of difference in calculation. The reason is because number of observations is also less, number of variable is also less, but you have to have P means a large number of variables with large number of observations. So, that individual calculation is not required, straight away go for matrix multiplication. We will be using simple matrix multiplication, matrix inverse and other things in throughout the I can say the lectures. Okay. So, this is what is mean vector, and from the population point of view and from sample point of view. From sample point of view, sample average is the estimate of population mean vector. Okay.